Now today we are going to start the new chapter as a magnetic effect of electric current. Now already this type of chapter you have seen in the 11th standard. And in 11th standard what we have seen that if we are considering a conductor, through that conductor whenever current I will be flowing, then due to flow of this current I, there will be a production of magnetic field around this conductor. And this production of magnetic field, that effect is to be called as a magnetic effect of electric current. And what will be the direction of that magnetic field? The direction of that magnetic field will be given by the Fleming by the right hand rule. What that right hand rule? That is, if I am saying this is the conductor and if that conductor I am holding in my right hand, outstretched thumb here. So this outstretched thumb indicates the flow of current. Then curled finger around this conductor will indicate the direction of magnetic field. This we have seen as a right hand rule. So now when here these current is flowing, means what? I can say that this is the conductor. Through that conductor current is flowing, means there is a motion of electron. So here is the presence of electron is there. So when I am saying that current I will be flowing in the upward direction, means there will be a flow of electron in the downward direction. Flow of electron means what? Charge. Charge Q is moving in the downward direction with certain velocity. So the charges are moving with certain velocity. So due to this motion of current, or in another language I can say that due to motion of this charge with certain velocity v, there will be a production of magnetic field. And this magnetic field will be produced. So I can say that if I am considering here is nothing but the flow of current, so there will be a production of magnetic field. So magnetic field I can show it will be inside the board. Then due to this action of electric current and magnetic field, the force will get exerted which is perpendicular to this axis. So that force will be acting on the conductor. And that force acting on the conductor is to be called as a magnetic force. So now, whenever a current will be flowing through a conductor, so your conductor is under the action of electric field and conductor is under the action of magnetic field. Due to electric field, the force exerted is nothing but Fe, whose magnitude is nothing but E into capital E, where E is the charge on electron, capital E is the electric field. And due to magnetic field, a magnetic force is acting. This magnetic force which we have seen last year, which is nothing but Q vector V cross vector V. So this is nothing but your magnitude of magnetic force and this is nothing but your magnitude of electric force. And together with these two forces I can say that the force acting on current carrying conductor will be nothing but Fe plus Fm. Where this Fe can be written as, I can say that if I am saying that this E is the charge on electron, so here also I can say that charge Q will be replaced by E. So I can write down this is nothing but your magnitude of your electric force and magnitude of magnetic force is E vector V cross vector V. And now if I take here as a, from this equation, if I am taking E factor common, I will write down vector F is equal to E into bracket vector E plus vector V cross vector V. And this equation is to be called as a Lorentz force law. So this is nothing but your Lorentz force law. Now under this Lorentz force law, you have two forces. One is nothing but electric force, another is nothing but magnetic force. Clear? This magnetic force magnitude is nothing but Q into vector B cross vector B. Now this magnetic force, in this magnetic force I can consider two special cases. The first case I can say that if your charges are moving with certain velocity v which is parallel to magnetic field. So if your charges are moving with certain velocity parallel to the magnetic field, at that time this angle between them will be nothing but 0 degree. And if it is 0 degree, in your cross product, what you will get it? This Fm, which is equal to Q V B sin theta if I solve the cross product. And if I put theta is equal to 0, your magnetic force will be coming to be 0. So in Lorentz law, when velocity of a charged particle is parallel to the magnetic field, the magnetic force acting on the conductor will become 0. This is first case. What is the second case will be here? In this second case, I can say that here, in the second case, if I am saying that is if your charge particle will be stationary, or I can say that charge is at rest. Charge is at rest means what? Velocity of that charge particle is 0. Velocity of the charge particle is 0 means what? Again your magnetic force will be coming to be 0. So this is nothing but the effect. Here I am getting where your magnetic field will be become as a 0. Now here in this case, what happens here? If I am saying that now your magnetic force, this is your magnetic force which is equal to nothing but Q into bracket V cross E. Q is nothing but charge. So either you can write Q or you can write down as a E, because mostly Q charge is nothing but electron and electron charge will be always written as a E. Now if I am saying that now here, that is one important case, that is if your charges are moving with certain velocity v along x-axis, therefore there will be a production of magnetic field along the y-axis. Is it right? Means value of v, I can write down vector v, I can write down as a vx into unit vector I. And value of magnetic field which is along the y-axis, so I can write down vector v is equal to vy into unit vector j. So now what your Lorentz force will act here? In Lorentz force law, I can write down your magnetic force Fm can be written as charge. So I can write down charge on electron is E into bracket, instead of vector v, what I write down? Vx into unit vector I. Clear? Cross. What is that? Vy into unit vector j. Means what I am getting here? E Vx Vy into bracket unit vector I cross unit vector j. And in 11th standard we have seen unit vector I cross unit vector j. Instead of that, I can write down it is equal to nothing but unit vector k. Means what I can say that the direction of force, magnetic force, will be along unit vector k. Unit vector k is along which axis? Z axis. Means your direction of magnetic force will be along a z axis. So in that manner, in certain questions, the direction of magnetic force will be asked. So the direction of magnetic force we can find out in this manner. So there are certain numerical problems. In that numerical problem, you can calculate in that manner. And this law is nothing but as your Lorentz law. Using that Lorentz law, whatever force we are getting, that force is to be called as your Lorentz force. Clear? So this is nothing but as your first point, that is nothing but the magnetic force. Fine?